SME's Composite Industry Awards honor those individuals and companies whose efforts and contributions advance composites manufacturing. Both recognized for their achievements in leadership, innovative technology, development and applications, continuous improvement, customer service, and education and research. Today's awardees inspire us to achieve greater levels of accomplishments within manufacturing. Here to help bestow the J.H. Judd Hall Composites Manufacturing Award is the Chair of SME's Composites Manufacturing Tech Group, Dick Laughlin.
Thank you, Dave. Good afternoon, everyone, and welcome to today's award luncheon. It's my pleasure to present one of the most prestigious awards, the J.H. Judd Hall Composite Award, Manufacturing Award. This award was created in 1986 to honor the late Judge H. Hall for his contribution to the development of composites technology and dedication to making the former Composite Manufacturing Association of SME an established community of SME. I don't know, when we make these presentations for the Judd Hall Award, a lot of people are probably thinking, well, who was Judd Hall and why did you make the award in his honor? Well, Judd was, back in the late 70s and early 80s, SME decided that this new thing called advanced composites would be a good technology to get into. So they came to Southern California and they contacted Judd Hall to kind of pull a group together. So Judd was the one that was instrumental in going out through aerospace primarily and finding like-minded folks who were interested in composites come together and form this composite tech group. So Judd worked for TRW. He was had several patents in composite tubing for spacecraft, and so he pulled this group together, and there was maybe hundreds of people that were interested in being part of this organization. But little do we know that Judd was fighting a battle of his own about that time. Judd had cancer and died at a young age of 51 years old. So at the time I was serving on the advisory board, and we decided that we needed an award, composite award recognizing people in the industry, and it was only appropriate that we name it after Judd. So of course the rest is history. We've gave several awards out over the years, and so today we're going to do it again. The Judd Hall Award is presented annually to an individual who has contributed to composites manufacturing, our tooling industry, through leadership and development or in improvement of processes, tooling, and applications, as well as achievements in composite research, education, and technology transfer. This year's recipient is Mr. Scott Lewitt. Scott is president of Structural Composites Incorporated. Scott leads his companies with a unique combination of outside-the-box thinking and flexible business practices. He's a subject matter expert on composites and develops innovative new manufacturing processes and automated manufacturing control systems, as well as new products. Scott's is a keen problem solver, creating and introducing one innovation after another during his career. He's developed numerous patents and expands his companies from R&D and testing into manufacturing. Scott's innovations have changed the composite industry, are well known, and used widely throughout the manufacturing sector. So with that, Mr. Scott Lewitt, would you please come forward?
That's really wonderful. Thank you, Dick. I really, quite an honor. It's very humbling. I'd like to thank SME and AeroDef for this award, particularly the Composites group and the award selection committee for recognizing a boat builder up here. I think I might be the first Judd Hall recipient that's a boat builder up here, so it's a real honor. Did a little looking online. It looks like I'm the 25th person to get this award, and it's just amazing that you've decided to put me in this club. So thank you very much. You know, there are a couple people I want to recognize that kind of shaped my career and helped get me where I am up here today. And the first would be my parents, and you know, they were a little ahead of their time. I grew up like a lot of kids, you know, very creative, open-minded, could do anything. And my parents, rather than try to ground me in reality, they let my imagination really run wild. And at a very formative age, I was never taught you can't do that. And that sticks with you your whole life. So for those of you that are raising kids or going to have kids, you know, it's important to keep that innovation alive. And when you're young, it's real easy to squash it. I think that was very important. Another person really shaped my career and direction is my business partner. He's not here with me. He's over teaching at Florida Tech, Dr. Ron Reichard. And so I graduated 1980 with my bachelor's degree in oceanography, of all things, and graduated valedictorian of Florida Tech, did real good, and was ready to go out to work, and Dr. Ron came along and said, no, you want to go to grad school. He just finished his postdoc, wanted some grad students, saw I was doing pretty good, started recruiting me. And I resisted, you know. I said, well, I want to go get a job, enough school, loans. I said, well, I'll help you pay for it. I'll give you a teaching assistantship. I said, well, maybe, we'll see. Then he goes, well, you can get to run the Bahamas Research Station in the summer if you do it. I said, deal closed. And that just changed my whole direction right there. Ron, at that time, was starting to look at all the materials that were coming out of the aerospace industry, and they were starting to trickle into the boat industry. And at that time, before boating, it was mat and woven roving, and that was the only materials we had. All of a sudden, core materials, knits, all these things are coming at us, and people really didn't know how to design with them and use them. And so we were at a very lucky time at that point, because you guys were doing a lot of the development in aerospace. We were pulling off of it and adapting it for the Marine. So, you know, I look at three areas that got me here, and one I would say is luck. The other is having a very collaborative approach and really valuing relationships with people I work with, you know, our coworkers and people we work with as customers and suppliers, and then being unconventional. Those three things, I think, help shape it. You know, luck is funny. Sometimes, you know, good luck's easy to identify. And, you know, I've had a lot of good luck. But sometimes luck you think is bad, but it actually is good. And I'll just give you a quick example. You know, back right around 2008, you know, we're in the boat building business. I'm an engineer running a company. We got 100 people, 2 shifts, making preforms, parts going into boats left and right. I got pretty good at growing. Then the downturn hits. I sucked at shrinking. Okay, it was hard. And we were, you know, just bleeding, because the customers are going broke, couldn't pay the bills, we couldn't pay our bills. It was tough. Fortunately, I had bought some Apple stock at $8, and I sold that, put it in the company. Sold a lot of other things, put it in the company. As a small business, you got to realize if the company goes, you go with it. You're guaranteeing all those loans. So as the success happened, and you start guaranteeing loans with ones, you know, 1 million, 2 million, you start thinking about if those go bad, what's going to happen to you. So you got to fight. So it's a real struggle. Then you come in one day, and then we get Tropical Storm Faye. And we get hit with 20 inches of rain in a period of 2 days. We're not in a flood area. Now we are. Okay? Everything floods. So you can imagine, you know, I'm literally in there making parts because we can't afford the employees. The place is flooding. Now you really think, all right, this is it, you know? And it turns out, you know, it's the flood. The flood saves the company. The flood saves the company. We didn't have flood insurance because we're not in a flood zone, but it made us eligible for federal disaster insurance or federal aid. We were able to get an SBA disaster loan at a time when the banks were pulling loans, okay, canceling loans, shutting down lines of credit. we were able to get this loan to help us recover from the disaster. Well, it did. It helped us recover from the disaster and bought us time. As we rebuilt ourselves, the business started coming back. So that flood you thought at the time turned out to be the flood that saved the company. In collaboration, I can't tell you how important it is. You can't do anything alone today. So having people you can trust and collaborate with, it's just so important to developing something. So we're a very open company. We try to share as much as we can, give away as much as we can. And we really like working with others. And in doing that, you're going to develop some deep relationships. And you know, as you move on in your career, now I'm getting to the point where people I've worked with are starting to retire, go off into other areas, you start missing them. So, you know, one thing I want to tell, especially the young people starting, you know, appreciate this time now. You're only going to get to see each other, you know, maybe once a year or twice a year at these shows. You know, how many times you're going to do it. So you may see somebody 20 or 30 times in your life, you know, so make the best of it because it's important. Take the time. And then being unconventional. This is the part that's fun for a small business because I get to make the rules. And we do things the way we want to do it. Sometimes it works out good, sometimes it doesn't. But we've always had a very technical focus. We've said, hey, you know, if we do the right thing, the business will come. Let's focus on the technologies and what our passion is. We made a commitment at the beginning that we wouldn't let the bean counters run the company. Okay, the bean counters work for us. And there were times as we started to grow, the bean counters started prying in, started telling us what to do. Why are you going to that conference? What was the return on investment? How much sales did I make? I'm going to tell you what, if you want to kill innovation, that's the recipe, okay? Innovation happens by doing going out, doing what you're not supposed to be doing the opposite of what everybody else is doing. So the business guys work for us, the bean counters work for us. We need them, all right? We need them to make sure we keep the doors open, the lights on, to help us get the money and resources we need so we can fulfill our technical objectives. A loose business plan. You know, if you don't have a loose business plan, it's going to be tough. We started this thing very, very ad hoc. I was able to get a big contract from the Navy to Dr. Ron at Florida Tech. He hired me in the college. We had no idea where we were going. Okay, we started out in a little barn in the college, got a little more work, were able to move out, started structural composites. You know, we invented the Prisma preform product. We grew that within the company until it got so big it couldn't take it anymore. Then we grew it out from that. The point here is always try to protect, you know, don't go for it in such a way that you're all or nothing. You know, you need to build that embryo so you have a base to work off of, something that's going to fund it. Build that base. It takes time. The other thing we've done is we never let venture capitalists in. We've never taken money from people who are here just to make money out of us. Every time we looked at it, the view wasn't worth the climb. So we took a lot longer to get to where we were going to go, but we still own the company, and I think that's important. Okay. So the way to go about it is you know where you want to go. You know where things are going to happen. What you can't control is you can't control the timing. You really can't. So we know there's huge opportunities for composites, just ginormous. When is it going to happen? Don't know. It's a confluence of events that has to come together at the right time. You can control some of them, but you can't control all the events. And so my method's been you keep pushing, you keep trying to bring that recipe together, and you wait for the confluence events to come together. And I think for us, I feel like it's really happening right now. We took an SBIR for the Navy in lightweight boats. We brought all our technology that we had into that SBIR. It led to a price performance gain in composites. We cracked the code. We figured out how to get our high performance composites with all the raw materials costing less than $2 a pound. That's a big crack of the code. All right, it came out of that marine industry. We knew it. We said, wow, this is great. We know what to do with this. And then we went out and we kissed a lot of frogs. All right, we showed people this. Most people said, no, I don't want to do that. I don't want to do that. I don't want to do that. Until we found somebody who did. Okay, Wabash National right here at the table. Okay, they looked at it. Wabash National is the world's largest trailer manufacturer. We just got lucky. Okay, got lucky. Walked in when they were looking for something just like this. We started collaborating. We started doing studies, looking at it and working it along. You know, in a very, very short period of time, a couple of years now, we've got platforms on the road, rolling already. All right, at the end of the month, we got a big show coming up. It's going to knock the competition. They're going to know what happened to them. All right, it's just amazing if you get the right partners. Okay, so in doing this, now we're opening up other markets that are going to come, because if we can tackle the price performance of aluminum in transportation, well, now we can go after better infrastructure, building construction. These are ginormous markets. The transportation industry is only 3% penetrated with composites. The building construction industry, 3% penetrated with composites. You know, if you look at Wabash, for example, they do 60,000 trailers a year. If I'm successful and convert every one of those, along with their team, to composites, yeah, it's about the size of the U.S. marine composites market, just the one customer. So it gives you an idea of the scale of the opportunity as we can break into these markets. And that's kind of led to this new business model that we're working. Because over the years, I've watched over and over again, small businesses, great idea. Big business comes, I like that idea, I'm buying you. They buy them. And then what do? It's like, what's the success rate? 5%? 10%? It's almost like a broken record. Big company comes in, not allowed to do this anymore. Can't do that anymore. Well, we don't do it this way. All the things that made you innovative and creative get stomped on by the purchasing company. And it's all because of liability. They're very liability averse. So we're working a different model. And working with all the different consortiums and traveling and visiting consortiums, I developed a business model where we're going to develop a kind of a closed consortium. So we bring in a few partners, okay, who are not competing, who are synergistic, and most importantly, partners who are willing to share technology, because that's the big opportunity. Technology, as we solve a problem in one place, if I solve a problem maybe in a trailer application, if I could use that in a shipboard application or a military application or an aerospace application, that's great. And if we can get these like-minded companies to come together to share among non-competitors, and then guess what? They're not going to own the company. They're not going to own half. They're going to own less than half, because I want to keep the small business in charge, do what we're going to do. So when they try to do all the things that the big companies do, we could say, no, we'll do it this way. Or if we want to take risk, we could take the risk. Okay, so it's a good experiment. We'll see how it is, and that'll be my next phase of my career. So we'll see how it comes out. Hopefully it'll come out good. So, you know, I'd like to close with, really take the time that you're at this show to meet new people, collaborate, make those connections, because you just don't know how those connections are going to hook up. It may be a week, it may be a year, it may be 5 years. Okay, it comes back, and it's important. Okay? So again, I'd like to thank SME for this award and this recognition. It's really appreciated. Thank you.
You don't even get the box you came in.
Thanks, sir.
Okay, thank you. It's now my pleasure to introduce an advisor and member of the Composite Manufacturing Tech Group, Mr. Dave Dixon of the Boeing Company, who will present the Excellence in Composite Manufacturing Award. Nice hand for David.
It's my pleasure to present the Composite Manufacturing Awards to a couple of companies that have really affected my career. Early in my career, I designed, or my group designed some of the tools that went on one of the first tape players that Cincinnati Millicron had marketed and sold to Boeing. And if you look at the awards and you see a company called Fives, forget about it. Sorry, I'm from Jersey, too. And it's actually pronounced Fives, so it's a French company that now consists of the old Cincinnati Millicron, Giddings and Lewis, Forrest Linné Machines, and Len Engineering. And I encourage you to go visit their booth right over here after the award ceremony. But as a pioneer in the automated tape laying and the manufacture of the first commercially available fiber placement systems, Fives Cincinnati, formerly Cincinnati Millicron, has been on the forefront of technology for composites laminating equipment, process, and software for the past 36 years. With more automated tape layers and automated fiber placement systems in operation than the combined total of all other manufacturers out on the marketplace, the technology from Fives has propelled the use of automation in composites across the industry, working closely with customers in the development of key products. The products and systems of FIV Cincinnati brand greatly influenced and promoted the use of advanced composite materials by the aerospace industry in both military and commercial sectors. SME is very appreciative of both the companies that are getting these awards. They've supported our conferences and from other organizations as well. Here to accept the award is Robert Harper, Director of Technical Sales of FIV Machining Systems Incorporated. Mr. Harper, would you please step forward? Congratulations. All right, got to get pictures here. All right.
Thank you, Dave. Thanks to the committee for such an honor. I'm honored to accept the award for FIV Cincinnati. As you know, the history that Dave gave you with Cincinnati Millicron up and through today being FIV Cincinnati, we've had several different owners. One thing's been consistent is our dedication to the composite industry. And yes, the first tape layers that we did deliver were for Boeing for the B-2 program. I believe that was in 1982. I think a total of about eight tape layers were delivered for that program. And it was companies like ourselves, pioneers, Ingersoll, also a pioneer back in those days for tape laying. Boeing, Vought, and Orbital ATK for coming up with the process. And it was companies like us and the Ingersoll that took it to market. If you go through the years, all of the programs, 1982, like I said, was the first tape layer for us in Cincinnati. We sold the first fiber replacement machine, which was this, we called a multi-laned tape layer back then in 1989 to Morton Thiokol, which then that machine was transferred over to NASA in Huntsville, Alabama. A gentleman by the name of Larry Pelham was very key to that in those early days. We spent many long nights in Cincinnati working in the labs trying to get these strands of material to go down on the part, just to stay on the part in those days. We moved forward to 1993. The first commercial machine that we sold for fiber replacement was the Boeing helicopter for the V-22. The majority of the fuselage for the V-22 at Boeing in Philadelphia is produced on fiber replacement machines. And then from there, at least in military, the industry started to grasp that fiber replacement and tape laying was a viable way to manufacture parts. We went on to the Boeing 777. The vertical and horizontal stabilizers became composite. On to the V-22, like we mentioned, the F-18 right across just north here in El Segundo at Northrop Grumman. They build most of the body panels for the F-20 or the F-18. The F-22 followed along. Then we had our first real commercial airplane, which was the Premier One, Beechcraft. They kind of flew under the radar. They built this two-piece fuselage, a forward and an aft, but a 360-degree fuselage, a 6-passenger jet on honeycomb core. It was the first time this had been done, automated. They built about almost 400 of these aircraft. They went on to build a 10-passenger also, which was an 84-inch diameter. In a three-piece section, again, 360-degree parts. From there, it started picking up in the commercial industry, which was Airbus, the A330, the A340, the Ariane 5. So now it was space or rocket launchers. So parts were becoming bigger, larger. And then it went through the A380, which then was the largest part, the rear section of the A380, which was built in fiber placement in composites, along with the horizontal and vertical that were built in with tape laying and composites, and then some of the flaps. The F-35 came along, and then it's the 787 parts are even bigger, the A400M, and then the A350. So as you can see, it's become industry standard now to use automation. You're going to see the 777X now as the next program, and then hopefully for all of us here in this at this conference that you're going to see future aircraft that are also. So again, I'm honored for FIV Cincinnati to accept this award. Thank you.
Okay, our next award is another company I'm very happy to recognize. I've had the opportunity to take a couple of classes at Aberus training down in Reno. And for those of us that work in engineering jobs or management jobs, in union shops especially, it's really hard for us to get hands-on experience working with composites. And Aberus training offers that opportunity where you can actually try things out and ask questions and work that type of a thing. So I know firsthand of the quality of their instruction and the value of that instruction that they have there. So Aberus has basically trained the world's composites workforce. They've trained impressively over 22,000 people from over 68 countries in composites. They provide composites training in engineering, manufacturing, tooling, repair, NDI training, and also provides consulting services to thousands of customers worldwide. They have worked with NASA, the FAA, and National Traffic Safety Board, major airframers, and others to help resolve problems. They have served as a beta testing ground for equipment and materials, providing feedback to the manufacturers of these products. And they have provided leadership in our industry with support to committees of high importance to our industry that deal with topics such as composite repairs. Finally, their support to SME and other technical societies has been fabulous. We are especially appreciative of the support of Mike Hoke, Aberus's president, Lou Dorworth, their division manager, and others at Aberus that have supported our composites manufacturing technical group in conferences from day one. So I encourage you to drop by their booth all the way at the end of this first row 100 over here and learn more about them. Without further ado, I'd like to invite Aberus's rep, Lou Dorworth, their division manager, to the stage and to ask you to give him a big hand.
Thank you, Dave. It's an honor to receive this award for Aberus. Aberus has contributed to many of the people that I see in the audience today. But before I go down that path, I'd like to congratulate Scott Lewitt on his award for the Judd Hall and for FIVs on their award for the large company. This award means a lot to Aberus because Aberus started in composites a long time ago as an offshoot and an after the fact of the Lear fan program. Many of you may not realize that Bill Lear passed away. Before he passed away, he had designed an all carbon fiber aircraft with a jet turboprop type pusher prop type aircraft, and he designed it with all carbon fiber frames, stringers, skins, etc. Basically an black aluminum design. Unfortunately, black aluminum designs don't work well, and we learned that very early on at Learfan, and by the time we knew that we needed to make some changes, the business had gone south. As a result of that, out of the ashes came a very smart group, an intelligent group of composite experts, and they started Aberus back in 1983. And at that time, Aberus did some prototype work, and they had one class for the military that was designed for composite repairs. And so we started there with one class, and over the years added on to those classes. In 1988, I was honored to pick up a couple of classes in Reno, Nevada, and start doing a second repair class and an introduction class, and also a tooling class. And back then, the tooling classes consisted of lofting and making your models with plaster and hemp and different types of materials that you wouldn't see out in the tooling shop today. But we taught what was state of the art at the time. Over the years, we've transitioned. In 1992, I started full-time at Aberris as the chief instructor, and Aberris took on a new meaning. Instead of just a few repair classes, we started to look at how we could help manufacturing. So we brought on manufacturing and quality assurance classes. We brought in non-destructive inspection training. We brought in tooling at a higher level. We converted to newer processes and newer materials. We brought in material and process science type training. We brought in engineering training. Actually started bringing the engineering training in 1991. So since then, Aberris has become pretty well recognized as the key composite training institution and services provider for the industry, and with a long record of working with all of the primes, working with many of their tier suppliers, and we're diverse, not only in aerospace being our very first customer, mostly military. Today we serve the wind industry, we serve the automotive industry. We have 2 automotive repair classes today, well ahead of the need, by the way, but automotive repair, carbon repair classes. We have repair training and such for the wind blade industry. We offer engineering analysis for repairs. Also joint design, design of composites, laminate analysis, a slew of different courses that have evolved over the years, and now we have over 26 in our off-the-shelf menu. In addition to that, we're able to allow our customers to tailor their needs. So many of our customers come to us and they say, well, we like the basic part of your introductory class. We would like our technicians to understand that. And then we would like you to specifically do some workshop events that involve our materials and our methods and our processes. So we're a very flexible company that way. And I currently am the manager of the direct services division, so I coordinate a lot of that type of work with people all over the world. And anyway, in closing, I want to thank the committee again for the very nice award. These are nice carbon fiber plaques, which is suitable for framing. And I want to specifically thank the Composite Manufacturing Tech Group for all of their support in this award, and thank my wife Heidi for attending with me today to give me moral support. So thank you all.